this is the progress so far, and the 555 circuit is still not soldered yet, but let me grab it and put it aside. But I finished the entire board. This is what I wanted to show you, and is as I showed you before, is having banded pieces of I see on the other side is banded. How they are called? Pads, metal pads, and metal sheet, you know. And yes, it's fitting excellently. I mean, I did a lot of back and forward movements. Yep, something like this. And those two pads are not touching at all. There is a 1 millimeter or less than 1 millimeter distance between them, because the pins of the chip are so close together, and it's almost it's perfect. I like it. So yes, this is the board finished. This is actually the second day, and it took me 3 days until here, because well, more than 3 days, 5 days maybe. First I had to make the circuit here to test, then I tested the first circuit there, then I had to draw it here, well, to resync it here, even if it's a copy from internet, this circuit. I still had to chat with my friends. I'm sure I can call them that. They are my friends. On AAC website, all about circuits, and it's not a sponsored. This is not a sponsored movie, but they do deserve a lot of praising, because they really helped me in their ways, and with very swift, very direct answer. No beating the bush around, and they helped me with getting to this stage. But yes, this took me a while, and until here. This is the fourth or fifth day until I reached this stage. I took a lot of breaks. It's very important not to stress yourself when you are building such a thing, and I wanted to say this before, but I couldn't say it because I forget it. Look how simple the circuit itself is looking, and look how complicated everything is looking here in the real board, because this will be the real thing. But the schematic thing is very simple and logical, and you can see it from one, you can understand it from one look. But here, holy fucking shit. you are, it's like a factory there. It's doing something. This is what I wanted to add. The time it took until this stage, and then I will make the other segment here and the other segment there, and we will put it to the test, and hopefully it will behave like the thing on the board, and I'm sure it will. Okay. Yes, I know it doesn't look like much, but everything is soldered, at least on this little board, and so here is tantalum capacitor. It's 10 microfarads. This here, and this is the 555. There is a resistor. Is this resistor 4.7 kilo, and here it is black, and this is also black. The second resistor here, another 4.7 kilo, and then a diode is plus and minus. So this is the diode, which is this diode here, pointing in that direction. So from plus to minus. This is the second diode, from plus to minus, and so from plus to minus towards the resistors, and the other diode, the second one, on the other side. I know it's reversed, it's like a mirror, but it fit my my circuit there, so this diode is pointing in that direction. Alright, and this is the capacitor, which is there, this one, and is the on pin 5, and it's on pin 5 here, and it's this one, 100 nanofarads. Right, this is scrapped, this is also scrapped. The resistors are new, and this is also scrapped, and the IC, the 555, is new. So I have 1, 2, 3 new, and the other 3 scrapped, but in perfectly condition, working perfectly. Alright, well, I didn't work as fast as I wished, because I encounter a problem. I reach, where is my trusty knife? Here is my trusty knife. I reached this stage where I had to insert, you can see it here, this 1 nanofarad capacitor, and is this guy here. This is a diode, this is another diode. These are the two diodes here, and this is how it's looking like here. You see this square, this square here is this part, as you can see, but in the continuation is this circuit, which is this little board here, and it's like this. You see, it's 1-to-1 scale. It's exactly the same size, and this is here. And I reached this part where I had to insert this capacitor, which is 1 nanofarad, like I said, and I got into a problem, and it took me I think more than a couple of days. I think 1 week. I believe it was 1 week. So 1 week from my last movie that I made until here. This is further in time, after 1 week. Because all these capacitors that you see them here very nicely on categories, with labels and everything. It was everything you see here, and trust me, it was hell. You can see from the back, especially these guys here, and some of them are so tiny. They are incredible tiny. And all this was a single pile of everything. And I said to myself to mm, uh, to make this catalogation and in time, but I never did put time in it, and I got mad on myself, and I said, "That's it. I have to make the categories." And here they are. After probably 1 week, I took a lot of breaks because you cannot work non-stop. It's your brain will melt by boredom. It's extremely boring to sort everything, and actually it's a story in itself. I don't want to explain too much, but I will say it very quickly. And I made a discovery actually with this occasion. Well, first of all, I use my ESR LCD ESR transistor tester, which, well, it's not practical. In one word, it is not practical. It's not that practical. I mean, it's not fast. It's practical for a couple of tens. If you have to measure a couple of tens of components, whatever they are. But in this case, capacitors, yes. So a couple of tens of capacitors, you have to wait until it is automatically turning off, and you have to wait until it's turning on again. And when you measure everything, you have to wait, and you are uncertain if you measured correctly everything, and you have to measure multiple times until you get the right value. And it's not really the tool for the job. For a couple of, I think I have 1,000 or probably 1,500 capacitors. All of them, they were not only capacitors, they were a couple of diodes, not many diodes, like 2 or 3 diodes, a couple of resistors, not that many resistors. They were so tiny I couldn't see them with my eye. They were infinitesimal tiny. And a lot of black things that always give me one on the multimeter. Here give me one here, like it was greater than 20 micro farads, but I discovered that they were just jumpers, what they are called, like 0 ohm resistors, you know, those jumpers. Instead of putting a resistive value or a resistor value on a specific track, they put a jumper, like 0, like a single wire, but in the shape of a semi-D resistor. It's a normal thing. They build it with these 0 links, and I didn't figure it out. I don't know why, but I didn't figure it out when I made the sorting before. And but now when I had to triage to sort every capacitor, to actually to measure every capacitor, because I did measure every single one of those little fuckers. And it blew my mind of boredom. I was so bored. It's unbelievable. But like I said, I made a little discovery. I am very lucky to have this awesome, a super digital multimeter, DMM, DT92058 is called. It's very old. Is from 2000 and something, 2002 maybe, 2005 maybe. I'm not sure really, but it's very old. It's already having 20 years old, two decades old. Probably older, maybe from 1998, maybe. I'm not sure. But the thing is that this guy, why I'm saying I'm lucky with it, because this guy is going down to 2 nanofarads and up to 20 microfarads. My discovery, I looked for capacitor meters, only capacitor meters, not multimeters with everything, but only having the capacitive range, and that's it. And they are annoyingly expensive. You don't really. They are too expensive, and they have the same range that a multimeter have, a little bit more. It's if this guy is having 200 micrometers, the capacitor meter is having up to 20 millifarads. So this is microfarads, and the next step is 20 millifarads. MF. It's a small m. It's for milli, and this is micro, nano. But the difference between these two, and I use the two of them actually. This guy is coming from 2 nano, is starting from 2 nano, but this guy doesn't have 2 nano, it's starting from 20 nano. But this guy here is the 20 nano, and here is the 2 nano. And with this guy, I have a chance to measure 1 pico or 10 picofarads capacitors, and it helped me immensely, this guy, for very small values. But the single handicap it has is not greater than 20 microfarads. So up to 20 farads and 20 microfarads, and that's it. But this is a bit one step further up, and it's having up to 200 microfarads, and it helped me for a larger values, like 30 microfarads, 30, 40, 100, of course, a lot of 100 no, not really. I didn't have the 100, but I had a couple of 30 or 40 microfarads semi-D capacitors like this guy here. And the discovery that I made, I looked into other multimeters, the new multimeters, and the new multimeters don't have this explicit scale that we have here. Is automatic. They are automatic. Everything is only pointing to ohms, capacitors, voltage, current, and that's it. But it doesn't say from where to where, the range of it. It doesn't say that. It's automatic. And you have to look into their specification. And I just did that. I looked in those multimeters, the majority of them, specification, and they have all of them. They are starting from 200 nanofarads. One or two I find from 20 nanofarads, but most of them from 200 nanofarads up to 200 microfarads, which is shit. Is absolutely shit. I am very disappointed of the newer versions of digital multimeters. They don't have enough range for capacitors to measure their value. There are multiple ways to measure capacitors, but the value of the capacitors This is what is doing the best multimeter. And the majority, well, like 50-50. I find a couple of them from 20 nano, but a good bunch of them, they were starting from 200 nanofarads, which is bullshit. It's bullshit. You should go down to 2 nano, on to pico even. If you say that humanity is progressing in electronics, and we are already in a high technological era, come on. This is bullshit. But this is the discovery I made, and I will close with this thing, because it was hell. It was really hell. So this is it about the capacitors, and next I will solder the capacitor and the potentiometer on this board, and continue to the rest of the board that remains here, this little part. Okay, now exception. So this is the fun part when I'm soldering the components. And keep in mind that all these pads are manually cut, bended, inserted here, and that's why I'm saying this is the fun part when I'm soldering them. It's very satisfying, at least for me, that I worked so much for the pads. Yes, I'm blowing air to yeah, I think it's good. It's a reflex for me. I'm always blowing cold air to help extinguish the hotness of the component, because I'm blowing air for the component to get colder and not remain too hot, because too hot is damaging. Usually is good. It will damage the component if it's too hot. If remains too much time too hot, pretty much that's the rule. I know the rule. Yes, I know right now at this point it doesn't have too much sense, but it will have sense and it will work when I will add all the wires, when I will put it on a bigger board, well, cardboard. I will stick every single module that I have here. I want to show you the back of it, and this guy as well. And yeah, that's it for this module. Wow. Right? Right? Wow. I soldered 2 components, but they are important. All right, this is it for this guy here. And next I have this guy here, which will have a transistor. Here is the transistor, 2 legs here and 1 leg there. and the rest of things. And it's this is the MOSFET. This is the transistor, and an LED with its resistor. Here is the resistor and here is the LED, and the motor will be here, and the diode. Yes, 2 plus, all 2 plus. So it's all there. And this guy here, from the leg of the transistor to ground, I think it was. No, to pin 3. To pin 3, which is the output. Yes, this is it. And yes, from pin 3 to the base of the transistor. Yes, it's a resistor, the 10K, the 10 kilo, the base of the transistor. The base, gate, because this is a MOSFET. So yes, this is it. Alright. I just finished this segment, which is this. Is it's like this. You see it? There, like this. And okay. And now I will have to solder the components on it. And let's put. And let's see. This is my box of CMD, but I have little bags, plastic bags as well, so 10 kilo. Let's see, actually let's see how many I do. I need 2 of them. So let's take 2 of them and 2 directly. Let's see how good I am. And an LED. I didn't thought too much on the color, which kind of what kind of LED to be. Yeah. White one. No. Orange. White one. No. By the way, these are my LEDs. At least this side until here. What you see with the dot, color dot, is they are LEDs, including these ones, which are white, but the rest are something else. And these are RGB LEDs. This is RGB. Should I use this guy? This is an RGB, but I burned 1 or 2. Yeah, it will work. It will do, I suppose. Alright. I hope. Let's see. I know this is plus, common plus, and the rest are the minus. And let's see if I'm lucky. I have to test it. Close. Opa, 12 volts, not 12 volts, 5 volts. Yep. Yes, the red is burned, but the blue in it is working. Okay, good then. This is half working LED, but it will look excellent, like it's new. I'm repurposing burned LED here. Burned LED. So this is the plus, which is common, and this. Oh, and a diode, which will be 4007, and let's see if the space is allowing me. This is for the motor flyback diode, reverse EMF to actually this is hard. Yeah, probably to work. Let me find something that is smaller a little bit, and the pins with smaller pins. Okay, 4007 is a bit chopped off, but is working. There. Let me test it if it's working fine. Yep, it's good enough. Actually, I have another tester especially for diodes and wires, only for wires and diodes. This guy here is only one battery, 9 volts battery, and a voltage regulator inside it. I made a movie about this some time ago, and if I'm doing this, it's crazy, but it's very practical, extremely practical, if you know where and when to use it. Not for everything. Definitely not in a circuit. Yep, it's working like that, and like this is not working, which is good. The diode is good. Alright. This is applying 9 volts directly. So actually the voltage regulator, I'm not sure. The voltage regulator is for the beeper. That's why I use the voltage regulator in it. It's not for the output. The output is 9 volts for that thing. Alright. So my soldering iron is this diode is actually chopped off, is cut off. I believe I took it from somewhere. It was a little bit longer, but now it's smaller. You can see the diode there. The junction. And yeah, a little bit of fun. Always be prepared. It's my motto. You know, prepare everything beforehand and then start to solder. So how do I need this? Towards the but this is just prepared here. So plus like this. Huh. Alright. No. Are you staying there? I have a ton of LEDs. Actually. But I'm feeling very good when I can repurpose something that was not good before. Let me test it again, because if I'm testing it again, where are you? 10 kilo. Hello, I'm here. I will feel if I'm testing it again. It's my way of doing things. I'm testing, and to be very sure. That's especially when it's on the spot and it's not working. Of course, it's not working. Motherfuckers! Why are you not working? Hmm? Motherfucker! Motherfucker! Now it will work. Now it should work. Let's see if I'm right. I am right? No. Motherfucker! Motherfucker! Why? This is problematic. More trouble. This is more trouble than I want. It should work. Aha, motherfucker. Okay, it was the other pin. This pin is burned. I soldered the pin that is burned. Okay. Damn it. Dang it. So again, I'm not abusing of this. On this RGB LED, I am repurposing, because theoretically I should throw it away. It's not an RGB, it's only two LEDs, green and blue, working. And I managed to be an idiot, and to burn one of them. Let's see now. Now should work. Will it work? Of course not. Motherfucker! Why the fuck don't you work? You are more trouble than oh, I believe he's making a short. That's why, because that burned LED is making a short somewhere. Let's see if it's true. Nope, it's not true. Opa. What the hell? Ah, I put plus. Weird. Weird shit. Very weird shit. Oh, alright. Wow. Okay.